Okay, in this lesson we're going to learn about how to simplify radicals because it doesn't always work out nicely where if we take the square root or a cubed root of it, going to be numbers left over. Let's look at this first example. Here this is the square root of 1500. Now 1500, that breaks down into 15 times 100. 15 breaks down to be 3 times 5. Those are both prime. 100 breaks down to be 10 times 10, and 10 breaks down to be 2 times 5. Now remember, this is a square root. The fact that if it's a square root, you don't have to have a number here. But if it helps, if you want to put a number there, you can. Remind yourself that we're looking for sets of 2. So we're looking for 2 of the same number here. I get to factor each set of 2, one number for each set of 2 out. So here I have a pair of 2's, so I get to take out a 2. Here I have a pair of 5's, so I'm going to take out a 5. And you multiply those two numbers together. So 2 times 5 is 10. What I'm left with remains under the radical. So 3 times 5, I can't factor those out, so that means that 3 times 5, or 15, is going to stay under the square root. So the square root of 1500 simplifies to be 10 times the square root of 15. Let's look at another one. This is a cubed root of 750. 750, that simplifies, or doesn't simplify, but two numbers that multiply together to be 750 is 75 and 10. 10 breaks down to be 2 times 5. Those are prime. 75 would break down to be 5 and 15. And 15 breaks down to be 5 times 3. And again, this is a cubed root. So for every 3 of the same number, I get to take one out. 1, 2, 3. So I have a set of 3 5's. So I get to take out a 5, but the 2 and the 3 that remain are going to stay under the radical. Now here's the tricky part. You can't forget, if this is a cubed root here, that your answer should have a cubed root. Okay, if you forget that cubed root in your answer, you're going to lose a whole point. So please don't forget to do that. If you have something remaining under the radical, make sure you check to see what kind of root it is. If it's a cubed root, put a 3 in there. If it's a fourth root, put a 4 in there. Well, what happens if there's variables? Well, just like in the previous video that we saw, these, you'll see where we're going to do the same process of what we did before, I should say. But let's start out with the cube root of 80. Well, this cube root applies to not just the 80, but applies to the x to the 6th, the y to the 8th, and the z to the 4th. So the cube root of 80, that breaks down to be 8 times 10. 8 breaks down to be 2 times 4. 4 breaks down to be 2 times 2. Don't forget about this 10 up here. That breaks down to be 2 times 5. So it's a cube root. So for every 3 of the same number, I get to take one out. Well, I have 1, 2, 3 2's here. So I'm going to end up taking out a 2. And then I'm going to give myself some space. You'll see why here in a minute. And I'm left with a cubed root of 2 times 5, or 10, under the radical. Now let's go to my variables. Now remember what we're doing here is we're taking the power divided by the root. 6 divided by 3 is 2. So 3 goes into 6 2 times. So we get to take out 2 x's. So x times x is x squared. Now let's go to the 8. 3 does not go into 8 evenly. 3 does go into 8 2 times. So I'm going to take out 2 y's, so y squared. But 3 goes into 8 2 times with the remainder of 2. So that means the y squared remains under the radical. And lastly, z to the 4th. 3 goes into 4 one time, so it gets to take out a z. But 3 goes into 4 one time with 1 remaining. So let's talk about those variables a little bit further. Let's go back to the y to the 8th. Y to the 8th is the same as 8 y's being multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. So this is the same as y to the 8th power. Now remember, it's a cubed root, so for every 3 of the same number, I get to take one out. So here I have a set of 3 y's, another set of 3 y's, and y times y is y squared. And I'm left with 2 y's left over. Those ones that remain, that are left over, remain under the radical. So the y squared stays under the radical. So that at least gives you a visual to see what's going on there. But it would be a pain to have to draw that out every time. So a better way to do it, like we were doing earlier. 3 goes into 6 2 times with none remaining. So 2 x's stay outside of the radical, x squared. 3 goes into 8 2 times, so I take out y squared. But what remain under the radical. 3 goes into 8 2 times with 2 remaining, so the y squared stays under the radical. For the z to the fourth, 3 goes into 4 1 time, so I take out 1z with 1 remaining, so 1 remains under the radical. So that would be your final answer. So why don't you guys try this next one on your own. So why don't you pause the video, hit play when you're ready to check your answer. So why don't you do that now. Okay, so let's see how you did here. So let's start by doing a factor tree for 48. There's a lot of ways you could get this started. You could do 2 and 24. We could do 3 and 16. You could do 4 and 12. You could do 6 and 8. Let's actually do those two. 6 breaks down to be 2 times 3. 8 breaks down to be 2 times 4. And 4 breaks down to be 2 times 2. So it's a fourth root. So for every 4 of the same number, I get to take one out. So there's 4 2's, so I get to take out a 2. And I'm left with a 3, but that 3 is going to remain under the fourth root. So now let's look at your variables. 4 goes into 6 2 times. 4 goes into 6 1 time with a remainder of 2, so 2 remain under the radical. 4 goes into 9 for the b. 4 goes into 9 2 times with a remainder of 1. And lastly, 4 goes into 12 3 times with nothing remaining. So there would be your answer for that example. Let's look at a couple more and then we'll be done. So this example here, we're looking at the cube root of 16 times the cube root of 20. When we have two roots, if they're the same root, we can combine these. So I'm going to combine these as under the same radical. So it would be the cube root of 16 times 20. Now if you wanted to, you could multiply these together. You'd end up with 320. But remember, we'd have to do a factor tree anyhow. And so then you'd be looking for, well, what are two numbers that multiply together to give you 320? 16 and 20 would be a pair. So in other words, instead of avoiding having to run around in circles here, when you tie these together under the same root, you don't have to actually multiply them together, because from here now we're going to do a factor tree for each of them. Oops. The 16 breaks down to be 4 times 4. 4 breaks down to be 2 times 2. 20 breaks down to be 4 times 5. 5 is prime. 4 breaks down to be 2 times 2. So this is a cubed root. So for every 3 of the same number, I take one out. 1, 2, 3 2's there, so I get to take out a 2. Then I have 1, 2, 3 2's, so I'm going to take out another 2. 2 times 2 is 4. I'm left with a 5. That 5 stays under the radical. So it'll be 4 times the cube root of 5. If I have variables, same thing holds true as far as the numbers are concerned. This would be the cube root of 90 times the cube root of 36. I really don't want to multiply those together. But my variables, we can combine these. This goes back to chapter 7. When I multiply variables and the bases are the same, we add the exponents. Remember that a here is just a to the first, so a to the first times a squared is a cubed. The b is b squared times b to the fifth would be b to the seventh. And now let's do a factor tree here. 90 would be the same as 9 times 10. 9 is the same as 3 times 3. Those are both prime. 10 breaks down to be 2 times 5, and those are both prime. 36 breaks down to be 6 times 6. 6 breaks down to be 2 times 3. And this would be 2 times 3. So this is a cubed root, so for every 3 of the same number, I get to take one out. So I have 1, 2, 3 3's, and I have 1, 2, 3 2's. So I get to take out a 3 and a 2, and 3 times 2 is 6. I'm left with 5 times 3, which is 15. This would be under the cube root. So let's see. 3 goes into 3 one time, so if 3 goes into 3 one time, we take out an a, with none remaining under the radical. 3 goes into 7 two times, with 1 remaining. So that 1b would remain under the radical. And there's your answer. So hopefully you have a better understanding of how to simplify radicals. Again, these are all problems you would do without a calculator. I suppose in the worst case scenario, when you do these with a calculator, you're just going to be looking to figure out what numbers multiply together to give you a particular number. But if I see decimals as your answers, I know you just use your calculator to get your answer, and you will receive no credit for that. So, knowing that, good luck on your assignment.